In this video, we're going to talk about some of the ways that we can abuse systems once we've been able to attack them. There's lots of different content in here, so we'll just kind of jump right into it. We're going to be doing a couple of different items in our network environment here, or our network diagram. There's a couple of different things we're going to be doing. First off is we're going to be attacking a website or services that are on this machine right here. And we're going to be attacking this by using what's called a brute force attack for passwords, utilizing a tool called Brooder. Once we're done with that, we're then going to utilize that attack to attack additional machines inside of the environment, specifically that XP machine, and then have them connect back in to our backtrack machine as running Metasploit. So let's go ahead and check it out. So first thing I'm going to do is I'm going to jump onto my backtrack machine and I'm going to do a scan of that IP address. So just nmap 216.111, and we'll see that fairly quickly we'll do a port scan across all of the devices or all the ports on that IP address. There we go. And we can see there's a list of services: FTP, Telnet, SMTP, HTTP, and POP that are running on that machine. As an example for Telnet, we can go ahead and Telnet into that. So Telnet 216.111, and we see that it is attempting to log in, but I think it should give us more information here shortly, but we don't have a username or password. Now we do know that this is a Microsoft FTP server. I'm sorry, that was a Telnet server. There we go, Microsoft Telnet server. So we do know it's Microsoft, so we do have a little bit of guidance of the fact that there's probably a user account named administrator. Well, if there's a user account named administrator, then that means we can try to log in as the administrator account. And that's where our Brooder service will come in. So let's jump on over to our Windows 7 machine, and we have a tool up here called Brooder. So traditionally, when we've been hacking user accounts, we were able to get a copy of the SAM database or the account database offline, and then we were able to attack the passwords there. What Brooder does is it connects over the internet or over the network and tries to brute force the account remotely. And so that's what we're going to be doing here. So I'm going to go ahead and set the target to my server, 216.111. The protocol is FTP, port 21. I want to specify a dictionary account or dictionary file. Let's go ahead and browse. I think I want this word list right here. I know that for this lab that this simple word list will work. If this was a larger environment that I was attacking, then I would choose a different word list. Once that's set, I'll click start. Now, again, what this is doing is stop, I missed one. I forgot to change the username. Username for Windows is not admin, it's administrator. So again, what this is doing is this is logging in via FTP to our FTP server, and it's trying the username administrator with the password of whatever the first password in that list is, and then the second password, and then the third password, and it's testing hundreds or thousands of passwords per second. We can see down here, passwords per second, about 1,400. So every single second I'm running about 1,400 different passwords against this service. Now, from a hacker's point of view, this is awesome. I'm able to connect up to this machine and just brute force some accounts. From a security admin point of view, this is a huge issue because these accounts should be locked out as soon as so many failed attempts have occurred. So this will take about 3 minutes to run. We'll pick up when it's done. All right, and as we see here, it took just over 2 minutes to complete, 2 minutes and 6 seconds. And we can see that it came back with a service of FTP, username of administrator, and password of p@ssw0rd. Highly insecure password that should not be used anywhere. Now, I will highlight the fact that this one should never have succeeded because the account should have been locked out. And then two, that this is an extremely noisy way to be able to do a password attack, because if we actually look at that machine right here, we can find log files that show that user account attempting to log in multiple times. Let's see, C drive, Windows, it's going to be System32, and then log files. Because this is FTP, it's going to be the MSFTP SVC, and I see the latest log file right there. And in this log file, I will see lots and lots of admin login attempts with lots and lots of failures. Yes, thousands of failed attempts. So it is definitely a very chatty system and should not actually work in a real world environment, in a secure environment, let me put it that way. But non-secure environments, it will definitely work. Well, let's try that. Let's see if we can go ahead and telnet into that. Now that we have a user account and password. So telnet 216.111. Should pop up here shortly, asking for a username. There we go. Am I sure I want to do this? Yes. Administrator. And then the password I see right there, p@ssw0rd. And it allows me to log right in. Great. So we've brute forced an account. We are now an administrator on this machine. That's awesome. Let's see some of the stuff we can do. Let's see. First off, let's make this a little bit bigger. All right. First, let's move back to the root directory. So cd /. This is where knowing some DOS commands comes in extremely helpful. Net start. Now the net command shows me a lot of different capabilities with regards to the machine. Specifically saying net start gives me a list of all of the started services on this machine. And make that a little bit bigger and do it again. And there I can see there's lots of services all the way back up to Microsoft Exchange. There's even more up above, but it's alphabetical and I can't scroll back to it. But let's go ahead and target this simple mail transfer protocol machine. Let's see if I can go ahead and stop that. So I'm going to do a net stop and then simple mail transfer protocol SMTP. And enter. And it says it's stopping the service. And now if I do a net start, once it's done, I should not see that in the list. There we go. It's no longer in the list, so I did actually stop a service on this machine. Okay, well, we talked about using this machine to attack other computers. So let's start off with that. This machine has a web server on it. So I'm going to change the web server functionality to fit my nefarious needs. So cd c:\inetpub cd www.root. And if I do a dir, I will see the files that are there. First thing I want to do is, well, maybe I'm a hacker and I wanted to see a larger list of the running services. I saw some up above, but there were just too many that scrolled off the screen. So I want to see what the full list is. So I want to save that list to a place where I can access with a web browser. So I'm going to do a net start again. This time I'm going to use redirect. A single greater than symbol means redirect to a file. And the file I'm going to redirect to is start.txt. Now I know Internet Explorer's Internet Information Services default file location is in C inetpub www root. So if I create a new file in that location, I can assume I'll be able to see that on another client through the web browser. Since I saved that as start.txt, I should now be able to browse to that IP address, 216.111/start.txt. Well, let's give it a shot. I'll try Mozilla here. So HTTP 216.111/start.txt. And there we have it. There's the list of all of the services that are currently running on the computer. Again, if I scroll down, I will not find the simple mail transport protocol because we already turned that off. But it does give me a full list of the other services on here that I may want to turn off or otherwise manage. For instance, FTP publishing service, that's actually how we hacked into this machine. Maybe I want to turn that off. So I will, let's see, can I copy net stop quote, right click and paste, and it stops the service. All right. Let's do the same thing for, say, Microsoft Exchange POP3, just because we can. And that stops as well. All right, well, let's confirm that this is actually making the effects that we think it's making. We're turning services off. Let's actually confirm that those services are off now and that the changes we're making are actual legitimate. I'm back here on my backtrack machine. Gonna up arrow a couple of times. We started off by doing this nmap command. I'm just gonna rerun that same nmap command. So we had just turned off FTP. We had just turned off POP. Why is it still there? Oh, they're there, but they're closed. Ah. So the services are now closed, even though FTP says it's open. If we FTP to it, we should not be able to connect. Service unavailable. Yeah. So even though nmap says the service is open, there's no actual process running on it. So we did a couple of things there. One, we brute forced the password. Modern systems that are configured properly should not have succeeded with that. But in our case, it did because we didn't have a fully configured system. Once we were done with that, we then used some net commands in order to modify the operations of the server. Let's continue on with that modification of the operations of the server, and let's actually make this machine an attack. So let's go back to our Windows 7 machine. Just to be sure, let's see, 216.111. We do have a website on here. I want to replace this website. There's a couple of different ways we can do that. First off, in my telnet session here that I'm hacked into, do a dir, and we'll see that there are some files here. See, there's the start.txt we just created. And there's also a default.htm file, which Internet Explorer shows by default. I want to rename that to something else. So under DOS, the rename command for a file is ren. So rename, and then the source, which is default.htm, and then the destination file, default.back. Now, if I'm a hacker, I don't necessarily need to keep the backup, but because I'm a ethical hacker or a penetration tester, I want to keep it just so I don't negatively cause issues to my client. At this point, if I refresh this page, I get the default Internet Explorer under construction page. Internet Explorer, Internet Information Services. Depending on the version of OS, that IIS landing page will be different. Well, let's replace that with something else. For instance, I want to have it say the website is down. Well, for that, there's a couple of different ways I can do it. I can do echo. For instance, the website is down. Now, the echo command on the command line does just that. It just echoes back whatever I type in there. But just like what we did before when we did our start.txt up here, I can redirect that to a file. So I'm going to redirect to default.htm. At this point, when I refresh the web page, I should get a message saying the website is down. Now, if I knew more about HTML at this point, I could have actually typed in more. I could have made this look a little bit more official, referenced images, and so on. That might have been a little hard for me to manually type, but it's entirely possible. Instead of manually typing it, what I'm going to do is I'm going to use a pre-configured error page. And for that, I have actually here on my desktop a deface.txt. And in here, we can see, make this bigger, some HTML code. Now, if you're not super familiar with HTML code, that's perfectly fine. We'll walk through it. First off is we start off with a tag called HTML, which references this as an HTML file. Next, we have an ahref tag, which means it's a file link or a link to some other page. And that specific link is going to be to this address, to this URL right here. That address just happens to be our machine that we are hacking from. That's our Kali machine that's out on the internet. The update location doesn't exist yet. We will create that shortly. And then a friendly version of that happens to be the same, but that's perfectly fine. And then /a. Oh, I'm sorry. It's not exactly the same. The link goes to 216.61.100, but the friendly version says 192.168.1.100, which would make the end users think that this is a legitimate place to go, even though the address goes somewhere else. That's the end of the A tag, and then and closing of the HTML. So I want to copy this and I want to send that into my default.htm so that when when people go to this website, instead of seeing the website is down, that they will see this content instead. So what I'm going to do is I'm going to copy that, edit, select all, edit, copy. So I've copied it all onto my clipboard. Now what I want to do is I want to copy that into my default.htm file. I could try to redo that with the whole echo command like I did up above. It's going to cause some issues because I've got greater than, less than symbols up here as well. So there's ways to do it, but it's kind of hard. Instead, what I'm going to do is I'm going to use copycon to default.htm. Now, traditionally, when you use the copy command, you do a copy, you do the source file name and then the destination file name. Here, I'm saying copy con, so the source in this case is the console or things I manually type on the keyboard. So I'll hit enter. We'll see how this works. And I'm just kind of stuck at a screen here. What I can do now is just right click and paste. And we'll see it written out to the screen. Enter, and yes. Depending on the operating systems you're in, sometimes you have to hit Control-Z, enter. Actually, I'm kind of surprised that didn't require me to hit Control-Z. Why is it not working? Well, let's see. Did I update it? Nope. I may have to restart this. Well, let's try that again. All right, yes, administrator p at ssw0rd. There we go, cd /inetpub. cd www root, copy con default.htm. There we go, right click, paste. Control Z on my keyboard and then enter. Yes. That should overwrite the file. All right, so I took a break and I figured out exactly what was going on. It turns out I'm working this through a virtual machine, and that virtual machine is not exactly friendly with the whole Control Z on my keyboard. So I had to find another way around it. But picking up where we left off, copy con to default.htm. I then paste in my text here, paste. And what I have to do is I have to open up the on-screen keyboard. So I'm coming down to the start menu here. I'm just going to type in keyboard, and I'll see, yep, right there's an on-screen keyboard. Make sure my console is selected, and I'll hold down Control or click Control and then Z. And then back to my command here, hit Enter. It says, do I want to overwrite? I will say Y for yes, and it overwrites perfectly fine. For some reason, my computer just didn't want to send the command across the line there. So with that being said, I'll close the keyboard there, come back to my page, and I refresh, and I'll see the new content. All right, so it looks like it is legitimate. It looks like it's going to an internal 192.168 address, something that you would expect to see. However, when you hover over it down in the lower corner of the browser there, you'll see that where it's actually going, which is 216.6.1.100, which is my external Kali machine that I'm using to attack these with. Well, let's jump over to the Kali machine and set up Metasploit, waiting for our victims to come join us. All right, so here I'm start off with the MSF console, and then we'll prepare an exploit for people to come join our machine. All right, so the exploit that I've already researched that I know I want to use is going to be the Windows/browser/MS09/002 memory corruption. If I do a show options, let me shrink this down a little bit. I can see required is the server host and the server port, and then we'll also be able to specify some payloads once we configure these. So set SRV host. That's my my IP, so it's going to be 216.1.100. I'm going to change the SRV port simply because, well, everybody knows 8080 is not correct, so I'll go ahead and set that to 80. Next thing I want to do is specify a payload. Payload I'm going to do is going to be the Windows/interpreter/reverse_TCP. And then set the local host for the payload to be me as well, 216.6.1.100. And then lastly, set URI path to update. Remember, the URL that we sent to our sending our end users to is a /update URL. So show options. And up here is our SRV port. I'm sorry, host and port. We're not using SSL. We could, but it's not really necessary in this case. So it will be 216.6.1.100/update. And anybody that browses to that link will go ahead and be told, yeah, install the reverse TCP shell and connect back to this machine on port 4444. So let's exploit and wait. Now we actually have a victim already lined up here and ready to go, and that is going to be this guy who's running on Windows XP. We're going to open up Internet Explorer. Now he knows that he has an internal machine, 192.168.1.100, that he browses to quite a bit and does a lot of work on. Now when he gets there, he sees that there's a message here saying, yeah, go to this link instead. Now, if I had planned this ahead of time, I could have made that link automatic, and I could have had it automatically go to this page and then possibly redirect back to where he thought he was going in the first place. But for this example, we'll do it manually. So again, if I highlight over it or hover over it, I'll see down in the address bar there, or in the status bar, the correct URL is going to 216.6.1.100/update, as opposed to the 192.168.1.100. So I click on that and it's broken. Yeah, from an end user's point of view, this is just broken. It was causing me errors to begin with, and I clicked the link and it's still causing me errors. So I'll come back later. But from a hacker's point of view, that's not broken at all. In fact, we could see, yeah, we started the exploit up here and it kind of sat and waited. And then we see, yeah, somebody just connected in. And we just got admin permissions on the machine. So at this point, I can do sessions-L, which should list the number of sessions. And I say I've got 1. Sessions-I1 in order to go to an interactive mode on it. And now I can drop user accounts or drop the password hashes, install software, exploit to other machines, pivot, and so on. All right, and then lastly, as far as for exploiting the systems, let's talk about a type of denial of service. Now, a denial of service follows with the CIA triad, the whole confidentiality, integrity, and availability. And this causes an issue with the availability portion. So for this, let's go back to our Windows 7 machine. Now what I'm going to do is I'm just going to set up a ping, a continuous ping. -T means continuous ping. So it will ping and continue to ping on and on and on. Now, I will warn you ahead of time, this may not work because our network, at least my network, is extremely resilient. And so this environment may not fail as expected to. But we can see, yes, we are pinging these addresses and the time is less than 1 millisecond. So it's a really quick, fast ping. Let's see. Next thing I'm going to do is I'm going to go back to my original Kali machine, my external machine, and yeah, let's get out of that. get out of Metasploit. And what I'm going to do is I'm going to use a command called hping. Now, hping 3 specifically. Now I'm going to be using this fairly simple with basically just a ping flood. hping 3 could do a whole lot more. For instance, can help me attack machines with both Christmas attacks as well as Smurf attacks. I'm just going to be doing a plain ping flood. So let's see, hping 3, if I do a -- help, that gives me all the options. I'm going to be doing a syn flood. So I'm going to be doing a -s, -S, specifically onto port 80. So if I scroll up, -P is the destination port, so the port that I'm talking to. So -P80. And I want to tell it to do a flood. That should be a -- flood. There we go, -- flood. So send packets as fast as possible and don't show replies. Traditional pings, you send out a packet and you wait for a response. And when the response comes back, then you'll send the next ping. So I'm just going to send a -- flood. And I'm also going to tell it to randomize the source. So -- rand - source. Make sure that's correct. There we go, random source address, which means instead of saying I'm coming directly from this IP address, it means I'm coming from sometimes this address, sometimes a different IP address, and therefore the responses will go back to whoever. Makes it a little bit faster with sending the packets. All right, and then lastly is the target IP, which is 216.111. So this is sending a flood of pings, a flood of SYN requests to that remote machine. So this is a SYN attack. If I go back to my Windows 7 machine, which is doing pings already, and I cross my fingers, I should start seeing my pings drop. But I'm not. And again, I will blame this on the fact that I have an extremely robust system and that these are all gigabit Ethernet adapters. And as much as I try to flood them, I can't necessarily. But let's try a little bit more. Let's go back to our Kali machine here. I'm going to copy and paste this command. Copy. And I'm going to open up additional terminals. Paste. And let's just see if I could do a whole bunch of these and possibly flood this out. Now, if this was actually on the internet, we're dealing at across the internet with much smaller bandwidths, and therefore it should be a lot easier to flood. Right there. What's going on with my screen there? No, still sub 1 millisecond timeframes. It looks like it's kind of hard to read, but it looks like there were some additional times when it was going slower. Let's see if I move this over, do another one. Yeah, just have too resilient of a system in order to allow this to work. But if this was an internet connection or a more traditional network environment, this probably would be working to where I could do a SYN flood against services and cause the server to run out of resources. So there you have it. Different ways of exploiting systems, either by brute forcing, by changing configurations on the web servers, or just by brute forcing the network traffic in order to cause it to go down.